All right, welcome to the rhombus video. A rhombus is a special type of parallelogram, and as such, it will exhibit all of the traits of a parallelogram. So I might suggest that you go back and watch the parallelogram video as well, which I will link in the comments of this one. And that will refresh your memory about parallelograms and all the unique things that they bring to the table. But because a rhombus is a special type of parallelogram, it has some unique traits itself. The most noteworthy one, probably, is that a rhombus has 4 congruent sides, whereas a parallelogram, the opposite side pairs are congruent. Here, all 4 sets of sides of a rhombus are congruent. The other thing that's very noteworthy, which you might be able to tell just by looking at this diagram here, is that in a rhombus, these angles created by the 2 diagonals, wow, that's really lopsided. But the angles in the middle there created by the intersection of the diagonals form right angles. So that's really noteworthy. That's going to allow us to do a lot of things. It also is key that the diagonals of a rhombus act as angle bisectors, which means that this little half is going to be the same measure as this little half. We haven't seen that before in any of the parallelograms so far, or any of the quadrilaterals so far. So this one is also going to be the same as that, because opposite angles in any parallelogram are congruent. And then the same thing will happen with this set, where these little halves in each corner are congruent. So lots of things happening here with rhombi, the plural form of rhombus. So let's dive in and see how you might see these characteristics of a rhombus used in problem solving in your geometry class or on the SAT or ACT. So first, let's look at problems involving the sides of a rhombus. Here, you are given algebraic expressions of 2 sides of a rhombus, and you're asked to find the perimeter. Well, the big deal here is that the sides of a rhombus are all congruent. So let's mark them congruent. 1, 2, 3, 4. Now, these 2 here that we have expressions for are congruent, so we're just going to go ahead and let me move this up a little bit here so we can get some working room. Let's go ahead and make them congruent. They have equal measures, so 10x minus 8 is going to be the same as 8x plus 2. That's going to wind up being 2x equals 10 and x equals 5. Now, going back up here, we can plug in that x equals 5 into either of these expressions because we should get the same thing. So 8 times 5 plus 2, well, that's going to give us 42. And if we did the math on this one, 50 minus 8, we'd also get 42, which isn't surprising. But then because this is a rhombus and all 4 sides should have the same measure, I'm just going to go ahead and fill in 42s for these. But we're asked for the perimeter, and we know that the perimeter of any shape, any polygon, is the sum of all of its sides. So we could do that math by doing 4 times 42. 4 sides that are each 42 units long, which is going to give us a perimeter of 168. So that's a question that you might see dealing with the sides of a rhombus. Now let's move to angles. Here we're given one angle. We're given an angle RMB. as 52 degrees, and we're asked to find all of the other angles. Well, what do we know about the angles in a rhombus? Well, one thing we know is that the angles in the middle are all 90 degrees. So I'm just going to go ahead and mark all those as right angles. Now, I want to draw your attention to the fact that this triangle here is one that we know 2 out of the 3 angles, because we know the right angle and we know the 52, of course. And we want to know, it would be really helpful if we could figure out this third angle here. Well, we can, because we know all 3 angles of a triangle have to add up to 180, and we can subtract the 2 that we already know, 90 and 52, which is going to add up to 142. So if we do 180 minus 142, that's going to give us 38 degrees for this angle here. Well, now we're ready to go, because we know that if this angle, we know that the diagonals act as angle bisectors. So if this angle is 52, this is also 52. And we've already done the math here that this is 38. So this one's 38. This one's also 38. And then we know that opposite angles are congruent. So this one here has to be reflected over here as well. And boom, we have found all of the other angles. We haven't seen this pattern before. The fact that the diagonals are angle bisectors in a rhombus is a real game changer, because the corners are going to look very different than they do, say, in a parallelogram or even a rectangle. Let's see kind of a more advanced thing here in a rhombus. The fact that we get right angles here in the middle will allow us to do some things here, because all 4 of these angles created by the diagonals are right triangles. So you may be asked to actually, let me highlight this one here, because we're asked to find OR like that. But we may be asked to use the Pythagorean theorem to find side lengths of some of these individual right triangles. Well, to find OR, it would be really helpful to find, well, I'll also highlight this right triangle. It would be really helpful to find this half here, and we can do that with the Pythagorean theorem. So I'm going to make this side here x. Pythagorean theorem says 1 leg squared plus another leg squared equals the hypotenuse squared. And this is going to 30 squared, we know, is 900. And this 34 squared is going to be 1156. So once we do this, it's going to be x squared equals 256. And if we take the square root of both sides, x will give us 16. So this side here is 16. And since in any parallelogram diagonals bisect each other, this up here is also 16. And 16 plus 16 is going to give us the full length of OR, which is 32. So that's just a glimpse into what you might expect with problems involving rhombi. I encourage you to check out my other videos on making a good series here on different types of quadrilaterals, which chances are you'll have a test on all of the quadrilaterals at once. So I encourage you to check out those videos in a group. I've made a little playlist called Geometry, and you can look all through that. I would also encourage you to drop a comment in this video if there is a topic in any branch of high school mathematics that you'd like me to make a video on. Let me know that, and I will add it to the list. Thank you so much for your attention. You're working hard. You're doing great. I appreciate you, and good luck in all that you're doing right now. Take care.